Alright, so hello everybody, welcome to CS 202. My name is Sam Black, I'll be your instructor for this course. I'm going to go ahead and let our TA, John, introduce himself as well, just here at the beginning. So you can go ahead, John.
Hey, can you hear me?
Yeah.
Alright, cool. Hi everyone, I'm John Tate, fourth year computer science student. I'll be your TA for this course. In terms of office hours, I just wanted to put it out there that I plan on holding them on Discord, on the Discord channel. I'm planning Tuesday and Thursday, because I'm home all day on those days. Probably 1 to 3, but I'm sure all that info will be posted somewhere eventually.
Sweet. Yeah, I'll get it on Canvas. Cool.
Cool.
Alright, well, thank you for introducing yourself. And as John mentioned, there is a Discord, which I'll show in a little bit as we go through the syllabus. So I guess we'll go ahead and take a look at that now. Really today I just want to go through the syllabus really quick, kind of fly through it, and then we're going to do a bit of a review for CS 135, and then maybe go into some new stuff if we have time, which I assume we will. I don't think it'll take too long to go over things. Is everybody able to see the PDF okay? Is the font alright? Do I need to make it any bigger? Looks good? Okay, fair enough. If at any point anything looks small, just tell me. Alright, so again, my name is Sam Black. Welcome to CS 202. I'm going to be holding office hours Monday, Wednesday, 3 to 5. Which is good. It seems like it's going to be the opposite day that John's hosting it, so we'll have it on opposite days. So pretty much every day you guys can get help there, and you can get help at any time pretty much on the Discord. All the instructors are there, as well as your fellow students, all the TAs, so you can ask questions there. There's a link on Canvas, which I should probably pull up here for a second. So definitely recommend going to the syllabus tab on Canvas whenever you get a chance. There's a bunch of information there. I'll put John's office hour information on there as well, but for the time being this has the syllabus I'm showing you now, and then it has the meeting link for this class that we're in right now, the WebEx room, and then my office hours, and then the Discord, as well as the YouTube playlist for all of the lectures here. Preferably try to reach me at email. I think that's usually the easiest way, and my email is just samuel.black@unlv.edu. Oh, that's a typo. There's no Nevada. Sorry. That's my student won't have that, but yeah, I'll fix that on the course later. This course is basically an extension of CS 135. So for the first part of this course, we're going to kind of extend upon that, learn some more programming structures, similar to how CS 135 went, and then we'll get into some more conceptual stuff as we go on, having to do with object-oriented programming and data structures and recursion and stuff like that. There are 2 textbooks that I was given for this course. The first one is the one that I recommend here. It's the Problem Analysis to Program Design. 8th edition is the one that they told me to recommend, but honestly I have the 7th edition. It was way cheaper and it is pretty good as far as a C++ textbook goes. The other one is free. There's a PDF for it here. There's a link to it. Although I've heard it's not that great. I haven't really looked through it all that much. But these aren't completely required. You don't have to go out and spend money if you don't want to. I do recommend the first one, though, if you're going to go out and buy a book. It is pretty decent, especially if you want to, just quickly look up something if you need a quick refresher on how to do it. Here's an overview of all the topics that we're going to go through. Roughly, we'll probably go through it a little bit quicker, if I had to guess, just from personal experience. So all of these topics will be on the first exam, all of these topics will be on the second exam, and then all of these ones will be on the final. And every exam in this course you can kind of expect to be comprehensive because, well, when you're programming, when we build on top of it, you're going to need all the stuff that we've done before as well. So there are 2 exams for this class, and then a final. It's 2 midterms, each worth 15%, and then there's a final worth 20%, and then the programming assignments are going to be worth the other half of the grade. There's going to be 10 programming assignments, I believe, this semester, and then so each one is going to be worth about 5%. Here's the grading scale. pretty standard. I don't think it's any different. I'll round up if you're close to being on the border. I will generally round up. I don't curve the final grade, but I will curve midterms and finals if the average is below a C, usually around like a 74. If it's below a 74, I'll typically curve it up. As far as the grading criteria goes, really the only requirement that I am strict on, and I won't give you an F even if it says that in the syllabus, is naming. So please name it CS homework or CS 202 homework number, and then whatever the number is, homework 1, homework 2, etc. Make sure, and yeah, I have a lot of students do this every semester that don't do this. Please make sure that you compile on a school server, preferably Sally. It does go down from time to time, so I understand sometimes you can't compile there, but please don't always just test it in Visual Studio. You can do that for like your setup. If you're doing programs, please make sure you test your final program on a school server like sally.cs.unlv.edu, because that's where we're going to do the grading, and it's important that we all have the exact same compiler version so we can have some consistency with the way that the program's run. And then the last part here is that we run every single program through MOS, which is a Stanford program that just is designed to check for similarities in programs that people have written. It's very good, pretty accurate, and so don't try to cheat, don't try to plagiarize off the internet or off any of your fellow students. Even if the assignment is done, because I have this happen every semester, even if the assignment is due, please don't send somebody else your program afterwards. A, because we reuse them, but B, because some of the sections might not actually be on sync with the homework, and so I feel like I catch that every single semester. And again, MOS is pretty accurate, so don't cheat. The other thing is, if your program crashes, then you will receive a deduction, which I think speaks for itself. As far as the breakdown for the grading, 20% of the grade will just be based off of your coding style and your documentation. Make sure you comment all of your functions, all of your class names, which we'll get into what that means later. And then you also use meaningful variable names, so don't just make an integer called x if it's going to do something really important. You can use that for like small variables if you're just like counting or whatever, but please don't use that for important variables. Make sure it is named something that has to do with whatever you're using it for. 20% of it is just going to be on general knowledge, which is a bit broad, but that includes not using any of the extra libraries that aren't mentioned on any of the assignments. I'll usually try to give a skeleton with all the libraries that you need. If you think you need to use an extra library, please just ask via email. You usually won't have to. And then the rest of it's just actually making sure that your program works. The rest of this is pretty standard. It's what you'd expect on every single other syllabus, so I don't think I'm going to go over it. Basically just says don't cheat, try not to turn in things late, although if you ever have a situation come up, just please send me an email, or if you need an extra hour to turn it in instead of what the assignment time is on Canvas, just send me an email and we can work something out. And I think that's about it. Last thing to mention on that, actually, other two things. The tutoring center and the writing center, I believe, are reopening on campus this semester, and they should still be doing virtual ones. I'm not 100% sure on that, but those are always options if you need extra help and we're not available. Yeah, I think that should be everything. The first homework is already up if you wanted to take a look at that. This semester we're doing it a little bit differently. All of the instructors, when they make a piece of homework, are going to record a video just explaining it. That way we don't have to take a whole bunch of class time. So check that out. It's on Canvas. It's due next Thursday. I have it set right now. And it's just a refresher on CS 135 topics. Any questions on the syllabus at all? Okay, cool. Looks like no questions. I'm just going to go ahead and close that then. And then I guess we'll get into just doing some review for CS 135. I'm going to do most of it in Visual Studio, so feel free to follow along if you have that installed, or whatever IDE or text editor that you prefer. I'm going to try to do everything via command line today so that we can get a refresher on that, but usually I'm just going to hit the green play button at the top because it's easier. Right, so I want to do a quick example just to go over all the topics from CS 135. So here I have a program that we're going to try to write. Let me zoom in a little bit. And I have two files that we're going to use with it. So what we want to do is, let's just say we're working for a, we'll be using, good question, actually. You will be using CodeGrade for this semester. So there should be a link to CodeGrade whenever you go to the assignment on Canvas. So whenever you go to submit an assignment on Canvas, it should link over to the tool, I believe, and then it'll give you automated responses. Yeah, thank you for reminding me, actually. If you haven't used CodeGrade before, for everybody here, it's just basically like an automated way to give you some feedback on your code when you submit it. It basically runs it, checks if your output is correct, and then also does some checking of your syntax and make sure that you're doing code nicely, I guess. Uses C-line for that. Yeah, good question. So for this example, I guess I have two input files just so we can do, two examples. And it's just going to be a list of items for a supermarket. And what we want to do is just read these in and then write them out to a file. And then we'll probably just do some extra stuff for the sake of reminding ourselves. And so each line of this file contains the SKU, which is just like the ID, and then the name of the item, the price that it sells for, and then how much of the item that there is. And we want to write a program to just be able to read this in from a file, and then let's just say write it out to another file. If we were writing a big program, we would probably do more with this, right? Sort these or do something like that. In fact, maybe we should sort these based off quantity for the sake of an example. So let's read all these in, sort them by how much there are, and then print them out to a file. So I have two files here, just called list1.txt and list2.txt. And let's go ahead and write this program. So if you remember, the main starting point of any program is always main. It's just where the compiler will start running a program. So I already have that here. And in C++, it returns an integer. We'll put return 0, which is just, lets it know that it finished successfully, which hopefully this will do. And then we hopefully remember that these include pieces of code that are in libraries that have been written by other people. So it just allows us to borrow their code essentially and not have to write it ourselves. IOStream is going to be used for printing. We want to be able to read from the file here, so I'm going to do fstream, and then I think that's actually all we need for this. I think we're good. Maybe just include string to be safe. I think it normally includes that. Yes, and we're going to use namespace standard. So the question in the chat was, are we going to use namespace standard? And I am going to just, as a tip, if you ever apply for a C++ position, they don't use namespace standard, which is why the template here didn't generate it. Although, for the sake of this class, yeah, that's totally okay. We're going to use namespace standard just to make it easy. And we'll talk about namespaces hopefully later if you haven't done that 135 already. Cool, so I think that looks good. Now, one thing we're going to need is an array to be able to store these all in, because we need a group of things here. So I could either use a vector or an array. If you haven't learned what a vector is yet, that's okay. We'll probably go over it a little bit later. And so for the time being, I'm just going to do an array. And so if you remember an array, at least a static array in C++, you need to set a size for it, and then that's going to be the size for the duration of the runtime. And we'll learn how to do it other ways here. So let's just say 500 is the max. In fact, let's call this array max, or just max size, probably good. Also remember that a constant is just a variable that never changes. So once this is set to 500, this integer never changes. So this is going to be the size of our array. And then we'll go ahead and make an array. So it's going to be an array of objects that are like shopping cart objects. So first things first, we need to set up how that works. Let's make a struct, and I'm just going to call it item for the items that we're doing. And remember that struct is a way to aggregate data, so this is just going to group everything together, and it's kind of like a blueprint, which we'll talk a little bit more about that in detail once we start doing some new stuff. Now, if you remember from this file, there were a few things that it had. So it had a SKU, the name, the price, and then the quantity. So see if you guys remember, what data type do you guys want to use for each of these? So what do you think we should use for the SKU? Int? Okay, perfect. I'm seeing a bunch of ints. You guys are right. So let's use an integer for the SKU. What about the name of the object? Okay, perfect. I'm seeing a lot of strings. I also see character, which not technically wrong. We can do it with a character, but it would be like a character pointer. We'll learn what that means later. But I'm just going to do a string because it's easy. And then what was the next thing? I think it was the price. So the price always has like the 2 decimal places after it. What do you think we should use for that? Okay, seeing a lot of doubles, which is fair. I'm going to actually totally just ignore the class, sorry, and go with a float. A double is totally okay. You guys are right, that's fine. I'm just going to go with a float because it's smaller and this is only 2 decimal places. And then last thing was a quantity. So what should we use for that one? Okay, perfect. Everybody's got it. And remember, if you want to declare 2 things of the same data type, you can do it in one line with comma. So I'm going to do that here, and we're just going to have a quantity. Cool. All right, sweet. Looks good. Now we have a struct called item, and this just describes an item that we can use. Let's go ahead and make an array of these. So remember, the way we declare an array is we give the name of the object or the data type that we want. Here in this case, that's an item, and then we give it, there's a bunch of different ways to do this, but I think the way that we're going to do this is we're just going to say items and then give it the braces and then put max size here. So this is how we do a static array. And so what this does, remember, is it just makes 500 items and it puts them all side by side, and then we can access them with a number. Why is this giving me a thing? Exceeds. Let's make this a little bit smaller. Hopefully the warning goes away. If not, oh well. That's fine. I'm not using that much memory. Okay, cool. So we've made an array of items, and then we want to do some reading. So if you guys remember, the way we read is with a input file stream. So if stream, which just stands for a file stream that receives input from it. And in this case, we can call it whatever. I'll just call it infile. And then remember, there's 2 different ways you can open a file. You can open it on the on the declaration itself. So I could put this, and then I could put the file name. So file name or whatever. Or I could do it later. We'll do it later because I want to be able to read it in from the user. And if you actually, I'll stop myself. Does anybody remember how we can get values from the user? From the command line specifically, so not via runtime, but from the command line. Okay, so I'm seeing a lot of cins. So cin is for runtime. If we wanted to get it while the program is actually running, we would use cin. And I do see somebody said argc, which you're on the right track. So argc is one of them. Do you remember the other one? argv, yeah, you got it. So if you want to be able to get things from the command line, which is the little interface with the text that we do, then it will be argc and argv. Right, and we'll do character pointer, which we'll explain what that means later. So just as a reminder, because I did see cin a lot, cin is for when you're reading during the course of the program. If we want to read something before the program starts via the command line, which is where you actually run the program, then we have to do it with command line arguments, which are these 2 things. Cool. So we'll go ahead and do that. What I'm going to do here for the usage of the program is, let's just say that the first thing is going to be the file name, and then that'll be our only thing here. So I'm going to create a string to read in the file name. Actually, I don't even need to do that. That's a little bit extra. Let's do some error checking first off. So the way we want this to be used is we want it to have exactly one argument. So make a comment here. We'll just say, oops, example usage is /, we'll just say a.out, and then the file name. So how many arguments, or what's the argc going to be if I run it like this with /, a.out, and then the file name? Is going to be 1 or 2, or something else? Okay, so I see 1, I see 2. Any other guesses? 2? Okay, fair enough. And you're right, it is 2. And the reason it is because, like was said in chat, a.out, the name of the program, whatever it is, in this case it's a.out, is included in argv, and so it's also included in the count argc. As a reminder, argc counts the things that are in argv, and argv is just a vector, is what C++ calls it, even though it's not like a vector, really, of strings where we just have a bunch of arguments. So the first argument in the arg vector is /, a.out, and the second one is going to be whatever they give. So what we want to do is we want to display a error message if the argument count does not match that, because that means the person used the program wrong. So what I'm going to say here is if argc does not equal 2, and it seems to be giving me an error. Did I? Oh, because I put aggrc. There we go. Right, so if argc does not equal 2, then we have an error. And so what we'll do is we'll let the user know that they used the program wrong. So we'll just say error usage equals, let me put a \n, and then /, a.out file name. Cool, and then remember that we can exit any function by just returning a value, and since main itself is a function, I will return 1. Now I need a semicolon after every line, but I'm forgetting to do that. There we go. And so this will check that. Okay, so that handles that. And then assuming at this point that we actually have the correct arguments, we'll go ahead and try to open the file. And so the way we can do that I suggested was we do .open, and then we just give the name of the file. Now, argv, we said, is going to contain all of the stuff, so the 0th argument is going to be that one, first argument is going to be that one, so this will be at position 1. Remember that when we're doing vectors and arrays that we start counting at 0, that's just kind of the way it works in computer science, and there's a good reason for that. So I'm going to do 1 because position 0 is a.out. Okay, so we'll open the file given. And then what we should also do is make sure that the file opened correctly. So maybe the file doesn't exist, or it's corrupted. If it's corrupted, it'll still probably open. But if it doesn't exist, or if somebody's moved it, or if it's being used by another program, then we probably won't be able to open it. And so we should usually do some error checking there. What I'm going to do is use the in file, and then remember we can do .good in C++ to check. So what I'm going to do here is check if it's not good. I've been writing it here for a second, but remember that the exclamation point is just not, so it means the negation of something. In this case, we said it was not 2, and here I'm going to say it's not good. If it's not good, then let's print an error message, and then bail. So here we'll just say error could not open file, and then we'll just give the name of the file so that they can see it. argv1 and line, and then we'll return an error again. Cool, so that checks if the file did not open correctly. And now that we've done all this error checking, we can actually get into the reading of stuff. So we said on each line that it has the SKU, the name, the price, and then the quantity. And so what we want to do is read all of those one at a time. So I'm going to do something here. I'm going to write it, and just pay attention. If you notice anything, just tell me. file dot uf. I need a not in front of that. So while we're not at the end of file, then I can read from it. So remember that we can do reading. I've just kind of been writing it, but remember that like the left arrow, the insertion operator lets you print things to a stream, and then the arrows go in the opposite way, make it go from the stream to the program. And I probably need to read some things here, so let me make a variable called count. We'll just set it equal to 0, and this will just read how many items there are. So count of items read. And then all we want to do is we want to read into the array. So here it is items. So size, so I'm going to do items sub 0. And then remember that the way we access members of a struct object or any sort of abstract data type object is with the dot operator. So the name will be dot name, and then the price will be dot price, and all that. So the SKU was first, and then I think it was the name, and then it was the price, dot quantity was the last one. And then I think that should be okay. So is everybody okay first off with me writing it like this with the array notation, or would you rather me write it a different way? I just want to make sure it makes sense. I'm shortcutting a little bit for the sake of efficiency, but all good. Okay, for sure. If you have any questions on it, just stop me. Would this be better in a loop so you don't have to rewrite this code? Yes. In fact, it would not necessarily work very well if it was not in a loop, because we would have to check like in each individual thing. So I'd have to actually, check if 200 times. I'd have to write 200 if statements, whatever that size is. And so you can see, like, if I had 1,000 things, that becomes really annoying, right? So if you either don't have an idea of how many objects there are going to be in advance, or you think it's going to be a huge number, then it's a good idea to do a loop. In fact, I would say anything more than like 2 or 3. So how would you rewrite that line? So the way I was planning on it, and sometimes I do encourage you to do it this way. It's not as big of a deal in C++ because it does some things differently than Java and C#, which is what I'm used to. But in those languages, I usually will write it this way, where I write a temporary object called temp, and then I would do in-file temp, basically do the same thing, temp.name, or temp.sku, temp.name, etc. I guess I won't write it all the way out. But I would write it the same way that I would write the other one, just with a temporary variable, and then I would set it into that. And I realized I did make a typo that I'm going to need to fix here. And then I would set it equal to temp, right? So I would go into the items array, and then I would just copy over the temporary variable. And there's a reason that we would do that in a language like C# or Java, and why I would suggest doing it on these, but it's okay in C++. The typo I had here was I put 0, so this was always just going to read into the first object, which is a mistake. Should be count. And then what I also need to do then is my count isn't increasing at all. So apologies that this goes off the screen, but it should work. So this still is just going to keep reading into the first object. So remember, plus plus, or plus equals 1, or equals count plus 1 will all make it count up by 1. I think this is the best way to write it. Right. So hopefully this should read into the object with the SKU, name, price, and quantity. I'm not going to run this yet, but does anybody see an issue with this? You may have had this happen to you before in 135. I know I have, and I see a lot of students make this mistake. Does anybody see a mistake or know what's going to happen with my code here? Yeah, okay, perfect. So somebody in the chat, I guess it's private, but so now everybody can see it, but it says that the file reads the last line twice, and you're exactly right, so good job. I think that's actually kind of hard to catch. This will read the last line twice. And the reason it does that is because end of file in C++ checks based off of file read errors. And so when we get to this, what it's going to do is it's going to read all the things, right? So it will go up to the top, right? The first thing this does in the while loop, when you do a while loop, is it checks the condition first, then it executes the code, then it checks the condition again, right? So it would check this, make sure it's true, do all this code, and then jump back up to the top and check if it's true again. If it's true, it'll always run stuff. And so end of file only gets triggered when a file read fails. And so if I did this one, it would read this first line, and then it would say, well, okay, I read all that good. Let's do the next one. It would read this one and would say, okay, I read all that good. That's fine. Do this one and this one, separately, and say, okay, read those fine. And then it would be at this point. So the pointer for the file would have finished reading the last line after doing all that stuff. It would increment count, and then it would go back up to the top, and it would say, all right, am I at infile.end of file? And it's not, because even though the cursor here is at the end of file in C++ is only triggered when the next read fails. So in order to actually trigger end of file, I'd have to read this garbage that comes after this 8. And so that doesn't happen here because it always reads the line first. And there are a bunch of different ways to check for this. I'll show you mine and then kind of show the way that I see a lot of other people check. So the way that I see a lot of people do, which is not bad, it's just a little inefficient, so I don't usually say to do it, is to just check for, we'd have to do each of these kind of separately, but to just check end of file like partway through the loop and then bail. So you could use a break. I'm not going to do it that way. Instead, what I'm going to do is I'm going to separate this one specific read, so just one read of the SKU, and I'm going to paste it outside of the loop. And then I'm going to put it at the bottom as well. And I'm going to remove it here. So what I'm effectively doing is I'm reading the SKU before I start the list. So I'm reading the first SKU, which is this one. And then after that, I read the rest of it, right? I read the name, the price, the quantity, as we kind of expect. And then I increment the count. And then I read the SKU of the next line. So try to read the SKU of the next line is what we're doing here. And so what this will do, right, is it will read that SKU, read all of this stuff, and then it will go and try to grab this. And it's nice because it's not going to get overwritten. And we also know that we incremented count, so it's going to go to the next position in the array. Right, so we do have that. And then this is also nice because if the file was completely empty, we do a read before we ever enter the loop, which means that the end of file will get triggered properly if there is nothing in the file as well. And so that's the way I recommend doing it because of that reason. There is one issue with it because of the fact that we have a count here, but that should be okay. Does that make sense to everybody the way I'm doing this here? Just because we have to trigger the end of file. If you need me to write it out, just let me know. I can draw a picture. Can you write it out? Okay. Yeah, I will do that really quick. So I'm just going to put a little EOF over here that just says false to start with, and then we'll say we have our file here. So I have a number, and then let's just say the name. I'll just do it like this. Let's not write out everything. So let's just say I have these 3 things, and then I have that, and then 7, let's just say. So it's a really short file. The first thing it starts with is just the file pointer starts here, right? So whenever we go through a file or any kind of stream, we have a pointer that points to wherever we've done all of our reading so far. At the end of the file is kind of like a null character, or just something that lets us know that we're at the end of the file. When we do a read, so when I do something like a reading in from the file into, in file, and then into the SKU, and I'm just going to shorthand this. Obviously it would be like items.SKU, but what this does, right, is it looks for whatever matches that data type. In this case, oh, and is this meeting being recorded? Yes, yeah, it should be. I think I hit record. Yeah, we're still going. This will be up on YouTube later. I'll try to post them on Canvas. But anyways, when we read into a variable, then it tries to match whatever that data type of that variable is. In this case, it's an integer, and so it'll look for the next thing in the stream until it hits something that doesn't make sense as an integer. Here, this will see the number 1 and says, okay, that makes sense as an integer, 2 makes sense as an integer, 3 makes sense as an integer, 4 makes sense as part of an integer, and then there's a space in the file. And it says, well, okay, space, that doesn't make any sense. That's not part of the integer, and so it stops reading there. And it will move the pointer up to wherever it stopped reading. So it finished the 1, 2, 3, 4, and then the space, which was where it knew to stop, and then it gets to the next part. And then if we read in a string, like the name, it will look for everything that makes sense as a string, aside from spaces and end lines. It does stop there, and so it'll read up till the end of the apple, and it will go there. And then if I did the same thing and read the quantity last here, then it's going to read that, and it's going to look for anything that matches an integer, because quantity is an integer, and move the pointer to the end. So by the time I'm done reading a line, the pointer for the line will be after the quantity, or at the end of the line. Now, if I did that again for the next line, right, what's going to happen is it's going to read the 3672 into the SKU for that item, the banana into the string for that item, and then the 7 in for the quantity of that item, and the pointer is going to end up over here. Now, end of file is still going to be false because of that. So this is just the way we were doing it before. If I read the SKU and then the name and then the quantity and don't do anything special, then we haven't read end of file, because it doesn't know it's end of file until it reads this terminating character. Or in other words, it fails a read. It realizes that there's nothing but garbage. And so in order to actually properly trigger end of file, we have to do an extra read to make sure that we do this extra thing. And so what I've been doing in the code there is I only read the name and the quantity, and then I read, in fact, it's probably just easier to show the code. I read this SKU first here, and then I read it before we jump up to the check for end of file. And so the reason that we do that, right, is that on each loop, it's always going to try to read the SKU of the next line and attempt to do that before we try to do another loop. So here, right, is it will read this. So this is going to be part of, this is read before the loop. And then the next loop reads all the rest of the stuff, and then does that. So on loop 0, it's all this green stuff. And then I'll try to use yellow in case anybody's colorblind. And then the next line, right, it's going to read the rest of it. And then it always tries to read the SKU of the next line first, so it'll read this. And so this will be loop 1 in this case. So the reason we try to read the SKU of the next line early is because the null character, or the garbage, is going to be in that position, and so it'll trigger end of file correctly. So if I do it this way, then the pointer will end up here, it'll be past the null, and it will say, okay, well, I've hit something that doesn't make sense to be able to read, and the end of file will get triggered properly. So we have a question. Because this is after count++, would it still read in the repeated value but only for SKU? So if I understand your question correctly, it would be basically, does it read the SKU into the correct position? And yes it would. Because of the count++, like you said, it's going to read correctly because we go to the next position, so count++, before we actually do the SKU reading. So, and because I also initialize count to 0, it will read this one into the 0th position as well. So this will read into the 0th position, it will read all of this into the 0th position. It will make the count 1, and then it will read the SKU of the first object. And if it doesn't end up reading that correctly, then that's totally okay, because it's going to trigger end of file, and we also have a count here to make sure that we don't try to access that garbage. So even if it reads badly and doesn't actually put the correct stuff, and it just puts garbage into this SKU member here, then it's going to be in a way that we can avoid accessing that bad data anyways. Hopefully that answers your question. Now, there is one issue with the way I've done this, and it's specifically if we read 500 things So this would specifically segfault if I did that. And in order to check that, I would need to put an if statement in here that makes sure that we don't accidentally do that. I'm going to be lazy, so this is going to potentially segfault if we have 500 or more objects, which is bad. You shouldn't do this. And the only reason I'm really doing this is to avoid putting if statements. So this is the whole reason I write it this way, is to avoid putting if statements in the extra thing there, because we're avoiding a check every single time. But I'll put a comment anyways. So, and while count is less than max size. Really, if we wanted to be also kind of lazy, we could just make the size 501 and then cheat a little bit. But that's okay. And just make this -1. But what you should probably do is put like if count is less than max size, just to make sure you don't go out of bounds. But again, I'm gonna be kind of lazy here for the sake of efficiency. Okay, so that handles the read, and I think this is probably the hardest part of this. I think it's kind of hard to wrap your head around reading like this. C++ is one of the few languages that does it this way, so totally understandable if it's a little obtuse. Alright, I think that handles the most important part. Let's go ahead and finish our reading by closing the file. And then let's just write out to a file. So let's write the output to a file. And again, for practice, let's just do this in a bit of a different way. Let's go ahead and write a function. If you remember, a function is just a piece of code that we can jump to at any point. And the way you have to do it in C++, you don't have to do it, but the way that's considered common in C++ is to give a function prototype which describes the function, and then actually write it later. The reason you do this is to highlight on main, and then the reason that it requires this is because the compiler does it as kind of like an efficiency thing. It only goes through your files once, whereas other compilers and other languages go through twice, but because it only goes through once, it requires you to do this. So what I want to do is I want to write a function that just prints each item, so I'm going to call it void print item. Remember that a void returning function just does an action and then doesn't return anything, and so printing seems to make sense for that. And what we'll do is we will print an item. Now I'm going to put an ampersand here, and then we're going to do that. Now why is it giving me declaration is incompatible with void print item declared at line 15. Oh, this is the declaration. Okay, there we go. Remember, for function prototypes, you don't actually have to put that. It's optional. Function prototype. And then it's common to, I think Visual Studio is just bugging out. That shouldn't be an issue. Then you usually write the actual stuff down here. If I put an ampersand, does anybody remember what that does for functions? Okay, so somebody said location, reference, pass parameters by reference, pass by reference, right? So pass by reference is the name, although you're not wrong when you say location, it does pass the location of it, although the technical term is reference. Yeah, so this passes a reference to the object, which we'll be spending a lot of time on references later. And that just means that rather than send a copy of it, it sends the actual variable itself. So any sort of change I do to this will be done to the thing afterwards as well. Now, if I do it this way without an ampersand, it makes a copy of the thing. For efficiency's sake, it's almost always a good idea to do it by reference. I think the error you're getting is because you're trying to use the type item before it's declared. Oh, you might be right. Thank you. Good catch. Yeah, so I should make sure that the type exists. Thank you. Good catch. Right. So generally, I would say always try to pass things by reference. It's one of the advantages to C++, actually. One of the reasons you would want to use it is it lets you do this. And if you don't want it to be changed, rather than make a copy of it, then you should probably throw a const in front of it. And what the const just means is that you can't change it, otherwise the compiler is going to yell at you. And so now if I try to do anything to this that will modify it, it will yell at me. Alright, that should be okay. And then I'm just going to write this to an output stream actually. So let me do an OF stream. I'll do this one as an ampersand as well, kind of has to be. And I'll call this output. In fact, let's just do it as an O stream, in case we want to change it later. I'm going to write a description here. So print the item to the given output stream. As practice, it's a good idea to write all of your descriptions above the function when you actually write the function rather than at the prototype. So this should be okay. And then I'm just going to print this, so we'll do output. Output is the name of the output stream. And then I'm just going to write something really simple. Let's just write skew. And then we'll write skew, and then end line, and then I put an extra O. Name. What was the next thing? Price. And I know I could be doing formatting with IOmanip, but I'm going to be lazy here. What was the last thing? Quantity. Oh, we also said we wanted to sort this, huh? So I should probably write that as well. Okay. I'm just going to throw an extra end line for the sake of making it look nice, and then we're just going to go through this array that we read. So I'm going to say for int I equals 0, I less than count, which is how many things are in there, I plus plus, and then we'll just print the item. And then we'll print it from the array. So remember, the way we access things from the array is just with these braces, and then I need a place to write it to. So I should actually open an output file really quick. I'm going to be lazy on this one. We'll just do it this way. So output.txt. And then, I need to actually give a variable. I'll call this out file. So this will print each of these items to the output file. And then I said I wanted to sort them too, so let's do that. Out file dot close. Sort items. And then I'm going to write another function for that, so we'll just say sort items, and then I will say items here. Oh, whoops, semicolon afterwards. Let's write that. So I'm just going to do another one up here that just says void sort items, and then it will take in an item array and a integer count. I'll do this one not with reference, just for the sake of the example. And I shouldn't give a name then. So one other thing, maybe just to point out. Why is it that I didn't put an ampersand on this one, but I did put an ampersand? Well, I put an ampersand on the other one for efficiency, but why is it that I don't have to put an ampersand on this one, even though I'm going to change everything? So int count. Oh, right. And in C++, it's like this. Yeah, okay, perfect. You got it. You can only pass an array by reference, and you're exactly right. So an array in C++, or in any language, is a reference type, and therefore always gets passed by reference. You can't actually put an ampersand in front of this. The compiler will yell at you. It just does it by reference automatically. And if it didn't do it by reference, it would have to copy every single individual item from the array to a copy, and that would be really horrible for runtime. So that's part of the reason it doesn't do that. Right, so this is going to be passed by reference regardless. Okay, so this just sorts the list of items with the given count. For the sake of time, I'm not going to explain bubble sort too much, but I'm just going to write it here. So let's just try to do a reminder of that. I'm going to do two counter variables called I and j, and then I'll just do a bool called isSorted. I'll initialize it to false. Really, I guess it doesn't matter all that much. And then, so we want to do 2 loops here. So I'm going to do 2 for loops. I'm going to set I equal to 0, I less than count. So remember that bubble sort is an algorithm that does 2 loops. The outer loop basically checks for how many things have been put into the correct position, and then the inner loop actually does the swapping, moves things into the correct position. What I should also do here is probably create item temp. I++. I will need to add one extra thing to that, I think. For j equals 0, j less than count, j++. So the outer loop counts how many things are sorted, and then the inner loop goes through the unsorted array. So the inner loop just goes from the beginning to wherever the last thing we sorted was. And I am missing something here. I'm going to need to add some things. So first things first, I need to subtract by I and by 1. So remember the way bubble sort works is it always compares 2 adjacent elements. We usually just say the pointer or the index is pointing to the left thing, and then we compare it with the thing to the right of it. So that's where the -1 comes from. It's just to make sure we don't go out of bounds, because we're always comparing it to the thing to the right. So we need to stop 1 early. And then the -I part is to make sure that we don't resort anything that we've already previously sorted. Which it would work fine if I didn't have it, but you know, it's probably not a good idea to just resort things if we already know that they work. Right, so just as a reminder, remember bubble sort just moves whatever the biggest element in the array is to the end, and it kind of like bubbles it up and moves things closer to where they need to go, which is why it's better than something like selection sort. So this is why we end up doing it. And also it has an optimization, which is what I'm going to do with this part. So we'll say and not is sorted. Right, so we'll keep looping while it's not sorted as well. And if you remember for the optimization, what we do is we say, okay, assume that the list is sorted, and then if we ever find out that it's not sorted, we'll just mark it that it's not sorted. And the way we do this is if the inner loop just checks things that are adjacent, things that are next to each other, we want to check if they're out of order. In this case, let's just say we're doing it in non-descending order, so least to greatest. Then we need to check if the thing on the left, which would be items sub j, is greater than items sub j plus 1. So what this says is if it's in the wrong order, greatest, then we actually need to do something here. Now I'm also making a mistake here. So you notice it's giving me an error on that, and I need to fix something. Why is it giving me an error? Does anybody know what the issue is? And if not, that's okay, because we are going to talk about it in a few weeks. Okay, so not seeing a response, which is okay. Probably didn't cover this in 135, so... Oh, actually, no, somebody got it. The compiler doesn't know how to compare an item. And you're right, the compiler doesn't know how to compare an item. And so remember that these are arrays of items, and what does it mean to compare an item to an item when it's like a custom thing that we've written? It doesn't really know. It's unclear. We can tell it what it is, actually. That's something that we'll go over in this class. But for just based off of like default, what happens when you write a struct, because it doesn't really know what that means. Now, the way we said we're going to do that is based off a quantity. So I'm going to write it here based off a quantity, but just consider that the compiler doesn't know, inherently that that's what I mean. So I need to write it. Cool. Good job. So that should be right. Do you have to compare it? Yeah, and somebody else said it afterwards too. Yeah, we have to compare the members instead. Cool. Good job. That looks good. So we got that, and then we need to swap these things. So this is why I created a temp variable. I'm just going to write this correctly. So we'll say items sub j, and then we'll say items sub j equals items sub j plus 1, and then items sub j plus 1 equals temp. And remember, the reason we need to use a temporary variable is so we don't accidentally overwrite anything. Okay, cool. So I'm just going to say this swap the two items. And then we want to say that if we swap them, we know that it's not sorted, because if it was sorted, then we wouldn't have had to swap anything because it would be in the correct order. And so this is the optimization bit. Okay, I think that should work. Let's go ahead. Oh, we already called it. I'm going to just write this here as well. Red counts items, and then we'll say that's fine. Okay. I think this program works. I assume so. So let's go ahead and try to do it on the server. Just make sure. Okay. Sorry, I saw I had a Discord message. Just want to make sure it wasn't a student. All right. So also, as a refresher, if you want to remember how to copy things over to school servers, at least on Windows, it's basically the same on other platforms. And I'm just going to use FileZilla. I'm going to go to the site manager. I have Bobby and Sally are on the same file system, so this should be okay. I'll connect. It'll take a second. It'll take a really long time, apparently. Is Bobby down? Let me check if the school servers are up. Well, let's use this as a chance to refresh on SSH. So remember that you can connect is just SSH, your username at whatever the server is. It's at unlv.edu. It seems like it's up. That works. Oh, there it is. Never mind. It just took a really long time to connect. I'm going to go to 202. Should probably make a folder for this class. Say fall 2021. All caps for some reason. CDCS. This on screen. CDCS 202/fall. Oh, because it's all caps, right? Okay. I'm going to copy that over. So on FileZilla, if I open that up, like the directory, I can just drag and drop it in Windows. So here I have the Visual Studio project. I'm just going to copy the source and the two input files that we said we're going to use. And it's going to take a while again. Cool, they're there. And then the compiler we use is G++. If you want to just do the default settings, you can do G++, then the name of the program, and I made a mistake. Too many arguments to void print item because my declaration or my prototype is wrong. I need to put a OStream on this one. Alright, try to compile that. Unfound reference to print item. Oh no, I have made some kind of error. Print item. I didn't say OStream, right? OStream? Oh, const. That needs a const. Okay. Now maybe my program works. If not, maybe I'll just try running it locally because I am apparently just forgetting how to program today. There we go. Okay, that time worked. Remember, if it compiles correctly, there's going to be nothing there, so we're good. It creates a output file by default called a.out, which is an executable that we can run. We can run with // do /a.out. And just to test that our program works, if I do /a.out, you'll see that it gives that error message we wrote earlier. So I got to type this correctly. /a.out. The name of the file, let's just say list1.txt. It says read 4 items, and then it should have also made an output file. So we see output.txt, which I can open with cat. And there we go. The formatting's a little janky because I don't have the 2 decimal places. I didn't use IONIP. Again, I said it was going to be lazy. But it seems to work just fine. And it sorts them from least to greatest. So it starts with the one with the least quantity, and then the next one, and then the next one. Which is not how it was written in the file, I believe, right? It wasn't 5, 6, 8, 9. It moved the chicken to the end, which is good. That's what we want. Cool. So that seems to be kind of just a quick refresher on CS 135 and all of those topics. Does anybody have any last questions on these before we get into anything new? Okay, don't see any questions, but if you have any, just feel free to either let me know or put in chat. Oh, would you mind explaining the use of argc and argv? Yeah. So let me reopen OpenBoard, wherever that is. It doesn't let me do a thing. There we go. Okay. And will these sample... Oh, yeah, actually, I forgot to mention that. Thank you. I will post any code that I write in class onto Web Campus on Canvas, and any input files that come with it, too. And just check the... Actually, I should mention, check the file section. It should be accessible by everyone, I think. I'll upload all the example code there, all the assignment information as well. Should all be on that. Right, so just a quick refresher on argc and argv. The way I wrote this last call was /a.out, and then I gave the name of the file, which was just list1.txt. So argc is a count of how many things there are when you run your program. In this case, it's 2, because there's this one and that one. And then argv is a vector, is what C++ calls it, that contains all of this stuff. So it's an array, even though it says character pointer pointer, it means an array of strings. And so the first thing is ./a.out. It basically just splits everything on spaces that it sees, unless you put quotation marks. So the first thing is going to be ./a.out, and the second thing is going to be list1.txt. So we can see here, again, that there's 2 things in the array, which is why argc is 2, and argv is going to contain the things that are read from the command line. So you can use this to get an idea of what the user actually wanted when they run the program, rather than wait until later. It also lets you automate things nicely. You'll see on assignment 2 that the person who wrote it used a makefile, which lets you write a bunch of stuff kind of like in advance on how you want the program to compile and potentially run if you write like a bash script. So, you know, it's very nice for automating things to use the command line instead. Any other questions on the CS 135 stuff? For the homework, do you prefer that we put our prototypes and function declarations in header files, then import them to domain, or can we all do it in the same file? Good question. I don't mind either way. You can do header files if you know how to do them. We'll go over those at some point, probably next week. So up to you. If you know how to use them, feel free. If not, these programs are so short that, at least the first program is so short that it's okay. Cool. So I'll keep an eye on chat. I'm just going to go over something new really quick. We'll just get kind of like an introduction, and then next class we'll go into more detail. What the last thing you learned about in CS 135 was a struct. And what a struct was is it was a kind of blueprint that tells you about data types that don't exist natively in the language. The way we wrote this last one is we made a struct called an item, and it contained a few different things. So it contained a SKU and a quantity, and then it contained a float for the price, and then a string for the name. Right, and so when we write this, it doesn't actually make anything, right? It's just a description of how the compiler should be able to do things. So a struct declaration is kind of like a blueprint. Or a recipe, you'll hear some people say. So it's almost like it describes how you would bake the cake. You know, it uses 2 eggs and 1 cup of flour, let's just say, and a cup of oil, and a cup of milk or whatever. But it doesn't actually make the cake. A recipe book doesn't just suddenly make a cake appear into existence. You actually have to do the baking yourself. And so when we write this, it's just a description of what we expect to be made whenever we actually want to use an item. And then to do a usage of any sort of variable, then all you do, right, is you just write the name of the data type that you want to create. Now we have our own created data type called an item, and whenever I write a new variable, let's just say x, then it goes off into space, quite literally, memory being space, and it makes something where it has an integer, and then another integer, and then a float, and it just puts them all together and stores them all right next to each other. And so this allows us to aggregate data with a string, which means that it just allows us to group it together. Okay, so this is an object. You also hear this be called an instance, which is what I'm going to start calling these from now on. They're interchangeable. I'll probably use both, but we're going to use the term instantiate. The process of making one of these instances or objects is called instantiation. So the difference here is that when we create a variable, that's an instance, and when we give a struct or a class declaration, as you'll see in a little bit, then that's kind of like a blueprint for the thing. So it's almost like, in real life, you might have some sort of description of a person. If I was to write a struct, person, and then they might have a name and an age and all that stuff. And then etc. They might have more stuff. And this is a description of a person, but it's not any individual person. So you might, go out and there's a person, I'll just use my name Sam, age 25, and then we have another person named Tom, who's 26 or whatever, and we're kind of like our own each individuals. We're our own instances where we have our own instances of our names and our ages, and they're kind of like separate and encapsulated by themselves. And so these objects that we're going to do are kind of going to be the focus of this class, is how we can get these objects to interact and how we can do special things with these objects. And this is going to be kind of like the basis for this course. Okay, so just wanted to mention that as a starter, because we'll be using it a lot. And the idea of using this is called OOP, which sounds silly. It just stands for Object Oriented Programming, which C++ is not super focused on, but it does support it. But it's what I'm going to try to focus on for most of this course, where we try to get these objects to interact in such a way, or that they are able to be self-contained and interact with each other and share things and stuff like that. Right, and so these objects, right, we've so far only been describing with structs. And so what we're going to learn about today, here just at the end of the class really quick, is a thing called a class, which is a little bit different than a struct. There's only one real difference. And it's basically that it's more self-contained by default than a struct is. So a class is declared in the same way as a struct. So instead of the word struct, you just use the word class. So I could do a class called person, and I could just do exactly the same thing, give it a string, name, integer, age, and what else that I want to put in there. Integer, age. I can also put functions. You can put this in a struct as well. I just don't think they cover it in 135 for whatever reason. So I could, do something called like void, print name or whatever. And I could write a function that prints the name of this person. That's all it does. dot. Right. That's not a semicolon. Should be there. And so the difference between a class and a struct is just the way that you're able to access data. We haven't actually explicitly written it yet, but a struct is what's called a public. All the variables are public by default, and all of the variables in a class are private. And all that means is, so let's go ahead and write this off to the side here. Public means that everything is accessible, and private means that everything is only accessible to the class itself. And so I'm going to put a plus and a minus here. I think a lot of the homeworks use this notation instead of writing the word public and private, but plus will mean public, minus will mean private. A public variable is one that is accessible to everybody. To everyone. Which is why we've been using structs so far. You noticed from the code earlier that I was able to just use the SKU and the name and the price and all that, and there was nothing stopping me. And a private is accessible only to the class itself. If I tried to write this class person here and then use it in the same way that we used the item in the code we wrote earlier, it wouldn't work because it would tell me that the age and the name are restricted. So they kind of lock it up and keep it to themselves. Which you might think, oh, that's a little bit strange. Why would you want to lock something up and keep it restricted? And so there's one main reason. So first thing I should probably mention, you can make things public in a class. It's just by default they're private. And in a struct you can also make things private, but by default they're public. So should probably add this is default instruct. And this one is the default for a class. And you'll see in practice more people use classes than structs. Rarely a case where you want to use a struct. And so we can make things public in a class, but you might want to keep things private if you're afraid of somebody messing with them. And so I'll give a really brief description here and just show the syntax. So the way that you make something public in C++ is you just put the word public before it with a colon, and then everything that comes after that will be public. So string name and int age. And now I could use this exactly like a struct. If I wanted to make something private, let's just say increase age or something like that, then I could put the private tag in front of it. And so the reason you do this is if you're writing a complex piece of code and you're expecting either somebody else to use it or even yourself, and you just kind of want to separate things for your way of thinking, then this is the way to do it, is to kind of lock off certain things, hide them from the user so that they can't access them. It won't show up in any sort of like suggestion in Visual Studio, and you'll get a compiler error if you try to use it. And this allows you to kind of guard things, which is the purpose of a class, and to make sure that you don't access it when you don't mean to access it. So really quick, I'm just going to end off with an example on that. If you have to go, by all means go, but just shouldn't take me more than like a minute or two. So over last summer, I wrote a program for mobile applications that was for our department that just lets you schedule lab appointments for the labs on campus, and it makes everything like socially distanced. So part of that was we have like a map of all of the rooms individually, and so each object in that is a class called a lab that I had, and so it just contains like all these seats, right? These contain different seats that are in the lab, and what we wanted to do was be able to fill them and make them like socially distanced. And I'm not going to worry too much about all the technical stuff about that, but the idea for why I use a class and why you would want to use a class is that you maybe want somebody to be able to set these seats and like be able to look at the seats and do that kind of stuff, but you don't want them to have like full control or like modify the way the lab works or move the seats around or do anything weird like that, right? So if you keep something private and you kind of guard it, then you can prevent it from doing anything strange or like unintended. And we'll see more examples of that as we actually do some programming here. And then just kind of limit the accessibility to whatever you actually want the user to be able to do with it, and then keep the things safe that you think need to be safe. Anyways, I think that's probably a good stopping point for the day. So thank you guys all for coming. I'll have office hours tomorrow. I assume John will have office hours this week, but I'll keep you guys posted. I'll talk with him, and I will see you guys on Thursday night.